Hey guys, so I'm going to be going over Note page 13 with you. Note page 12 we finished on class on Thursday, so if you need access to Note page 12 or you need the answers for Note page 12, please just let me know and I can help you with that. So Note page 13 is really talking about distance formula and Pythagorean theorem. Hopefully you've heard about Pythagorean theorem before. So Pythagorean theorem is essentially your a squared plus b squared equals c squared, and it basically talks about how we can use right triangles to find any sides of a triangle. So when we talk about it in regards to coordinate geometry, typically what it means is that we're finding a distance that's the hypotenuse of the triangle. So to help us use Pythagorean theorem, we want to create a right triangle. So to create a right triangle, we draw in our sides. Now, if you didn't want to do an upside down triangle, you could have also done a triangle going to the bottom and the top here, and that's fine. And what we would want to do is we want to count the boxes that are on each side, and then essentially what we're trying to figure out is the unknown value, which is the x here, okay? So when it says create right triangle using AB as one of your sides, this is what we just did. Now it wants to identify the coordinates of A, so A here is -2, -1, and it wants to know the coordinate of B, so B is 1, 3. So when we're using Pythagorean theorem to find this distance, we want to remind ourselves that A and B are always going to be the legs, and it could be interchangeable. So A could be 4 or A could be 3. But what's really important is that C is always going to be your hypotenuse. Okay, so when we're looking at a right triangle, you want to have C always be the hypotenuse of the triangle. And the hypotenuse is basically the side that is across from your 90-degree angle. And typically, it's usually the side that we're trying to solve for. So just to kind of remind you about how Pythagorean theorem works, I wanted to go through a couple of these. So if your side is unknown, is B, then you want to remember that you want to do exponents first. So 3 squared is 9. And 5 squared is 25. And then to get B by itself, we're going to have to subtract 9 to the other side. And then remember that we can't just leave it as this because we have an exponent. So like what we talked about in our note page 12, to undo an exponent, we're going to use something called a radical or square root. So we're going to take the square root of b squared and the square root of 16, and so then b will actually equal 4. Now, sometimes we can get approximate values, and sometimes we're going to get decimals. So for instance, if I used my calculator here and I typed in the second square root of 16, I'm going to get 4, okay? And sometimes it's going to be a decimal, and that's going to be all right too. Now, for the most part, most of the time for using Pythagorean theorem, we're going to have something that looks like B, where we're trying to find the hypotenuse side, so that's going to be our unknown. So again, we're going to do our exponents. So 5 squared is 25, and 7 squared is 49. And then we're going to add these together. So instead of subtracting them like what we did here, because B was our unknown, since C is on the right side, we're going to add these together. So when we add these together, this gives me 74. Now, the biggest mistake that my students make with this is they either, 1, leave it exactly like this, or 2, they do 5 squared is 10 and 7 squared is 14. So remember, it is not 5 times 2, but it is 5 times 5 and 7 times 7, okay? So then we want to take the square root of 74 and the square root of c squared. And so what you can do is you can either leave it as the square root of 74 and give it to c, or if you want, you can figure out what that is in the calculator. So if I plugged in 74 here, I'm going to get an exponent, or I'm sorry, not exponent, I'm going to get a decimal. And you want to round always to the nearest tenth, so one number after the decimal. So this would be 8.6. So you can say C is either radical 74 or 8.6. Okay, so we're going to skip C for now because C is essentially the same as A, but you kind of get the gist of how we simplify using Pythagorean theorem. So Pythagorean theorem, again, is useful in finding the distance of our hypotenuse. So now we're going to actually look at distance problems using our coordinate geometry. So when we are asked to find a length of a diagonal, the first thing we always want to do is we want to create that right triangle. And like I said, it doesn't matter whether the right triangle is going to be on the bottom half or on the top half. The second thing we want to do is we want to count the boxes. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8, so that we know what the lengths are of A and of B. And then what our unknown is going to be this unknown of CD here, okay? So then we're going to use Pythagorean theorem to find this unknown value. So we're going to say 8 squared plus 6 squared is equal to our unknown squared. So you can put x squared or you can put c squared. You can put any letter squared here. So 8 squared is 64 and 6 squared is 36. And like problem B, we're going to add these two together. So we get 100 is equal to x squared. Now remember, we don't want to leave it just like this. We want to take the square root. And luckily, the square root of 100 is an even number. It's going to be 10, okay? And so this is going to be the length of our unknown side, so our CD side, okay? Now, E is very similar to D. The only thing that it's different about E is that the line is not drawn between A and B, so you just would want to connect it. And again, you would still start exactly the same way. You would count the sides, and you would draw the right triangle. And you would then go ahead and set up your Pythagorean theorem equation. So you'd have 5 squared plus 4 squared equals x squared, okay? Now, I'm not going to do this one with you, but if you want to try it, you can. It's the same premise as D. Just remember that when you're connecting them, that you want to be on the line, except for the diagonal, and you want to make sure that you're counting the boxes so that you know how many boxes there are, okay? Now, another way to figure out distance instead of using Pythagorean theorem is something called distance formula. It is not my favorite, but it's something that you can do. I recommend, if you really understood the Pythagorean theorem, that anytime you're given 2 points, draw them on your coordinate grid and then go ahead and use Pythagorean theorem. But if you don't want to draw them, something you can do is use something called distance formula. So distance formula is this long thing right here, and it's kind of confusing, but basically the premise is that you're going to label your points x1, y1, x2, y2, and then you're going to plug them into this formula. And like I said, again, I'm not a huge fan of this, but you can use it if you want. So we have -1, which is x2, minus our x1, which is 2, and then squared, plus our y2, which is 1, minus our y1, which is -3. Biggest thing that I don't like about distance formula is this double negative. A lot of people forget to put the double negative in there, and so then they end up getting the wrong answer, and so that's where it's kind of confusing. So -1 minus 2 is -3, and then 1 minus -3. So remember, 2 negatives equal a positive, so this ends up being 4. And then the other thing that really my students struggle with is this concept of -3 squared. So -3 squared is actually 9. It's not going to be a negative value. And a lot of my students, when they plug this into their calculator, they don't include the parentheses. So you have to include the parentheses. So for instance, if you see this, look at, if I put in -3 squared without the parentheses, it's going to give me -9. But with the parentheses, it gives me +9. So it's extremely important that you include the parentheses in your problem. So then 9 plus 16 is 25, and then the square root of 25 is 5. Okay, so this is how you would use distance formula to find the problems. But again, if you feel more comfortable with Pythagorean theorem, you can always graph these points on a graph and then go ahead and connect and solve. I'm going to just show you this one really briefly. Again, x1, y1, x2, y2, and then we're going to go ahead and plug it into our formula. So we have our x2, which is 1, minus our x1. And then we have our y2, which is 3 minus 0. And so 1 minus 5 is -4. And 3 minus 0 is 3. And then we would have -4 squared. Remember, this should never be negative, so this would be 16 plus 9. And then you'll notice that we end up getting the same thing. 16 plus 9 is 25. And then the square root of 25 is 5. Okay, so again, if you want to use distance formula, you can, but my go-to is usually Pythagorean theorem. Now, if you want to summarize this or do this with me, you can, or if you want to pause this video and try this one on your own. But this is basically showing both methods. So notice that both methods should give you the same answer. So if I use Pythagorean theorem, I'm going to draw my right triangle. And I'm going to label my side. So I have 3 squared plus 7 squared equals c squared, which is my EF. So I have 9 plus 49 equals c squared. So I have 58 equaling c squared, and then I have to square root that. And then that would be my c, okay? And if I wanted to do the square root of 58 in my calculator, I could, and that would give me 7.6. If I wanted to use distance formula, I need to know my points. So one point is -3, -2, so that's E. And then the other point is 4, 1. So again, I want to label x1, y1, x2, y2, and I'm going to go up to this formula that I have here. So I have a big old radical sign, and I'm going to have 4 minus -3, and then I have 1 minus -2. So 2 negatives equal a positive, so I'm going to have 4 plus 3, which is 7. And then 1 minus -2, same thing, 2 negatives equal a positive. So I have 3. Notice that you're getting 7 squared and 3 squared, which is the same as you got on Pythagorean theorem. So 7 squared is 49, and 3 squared is 9. And then the square root of 49 plus 9 is 58. Okay, so which would also be equivalent to 7.6. So notice that the answers are exactly the same whether you use distance formula or Pythagorean theorem. So what I'm going to have you guys try right now is I'm going to have you try worksheet 13. So worksheet 13 is a little bit of review from your previous notes, and then it's also going to be using the distance formula and using Pythagorean theorem. If you feel more comfortable with number 2 using Pythagorean theorem, go ahead and draw a picture to it. If you feel more comfortable with distance formula, then go ahead and use distance formula on both of them. But you do want to complete all 1 through 8 for worksheet 13, and then again, zoom in with me if you have any questions. All right, thanks so much, guys.